The European Space Agency's LISA, the Laser Interferometer Space Antenna, is a Pathfinder wave mission. It's set to blast off Thursday, just in time to celebrate the publication of Einstein's theory of relativity 100 years ago this year. Now, Einstein, he predicted the existence of gravitational waves in 1916. LISA is searching for those ripples known as gravitational waves. They're caused by fast-moving, massive celestial objects. The LISA will be carried aloft by the Vega rocket and enter the LISA J orbit. About an 8-week trip. Jose, this launch, it's on the hunt for Einstein's space and time ripples. So I actually had to Google this myself and get some more information, because a really interesting theory. It says that matter and energy, they're two expressions of a single material, and they've actually launched this Pathfinder into orbit in search of exactly what he was talking about in 1916.
Correct. And I think it's very, very important, because it's something that would allow us to understand and map the universe and space in a different way. And just to confirm theoretical knowledge from almost 100 years ago, it's incredible to see that people is still trying to confirm the thinking of Albert Einstein, so influential. And what are the expectations of this mission?
Well, there are several. So gravitational waves, they're in low frequency range. So they want to actually identify those waves. That's one element of this. And these waves that are traveling in low frequency, they're measurable. So they're hoping to get test results because of this mission as well. So really amazing, this low frequency gravitational wave. It's caused by a one bar. It moves in the tiniest way. And you know, if you read anything about his theory, his original publication, it's so fascinating, you know, talking about how matter and energy, they're part of the same material. So he's telling us to think of space and time as a fabric, and the presence of these large amounts of mass energy, it distorts space and time, and they're looking for these distortions as well with this amazing Pathfinder.
I hope that they bring amazing results, and the applications that this could have are plenty, and it's just a matter of them to actually find them so we can develop more knowledge out of them.
You believe they exist?
I mean,
his ripple theory, these ripples?
I trust Einstein.
You do? You stand by
him? A little
it?
bit. I stand by him.
Well, this was just one aspect of his theory of relativity. It was one little element of it, but it's so fascinating that we're seeing this. 2015, we're just now doing this, and it's not us, unfortunately, it's the European Space Agency doing this, and you know, wanting to identify these gravitational waves. What this could mean for us in terms of travel, specifically
the changing the rules of physics. Yeah, exactly. Well, that is the most important part of this type of research, is the idea that we're gonna hit a threshold where we're gonna get some new understanding of how space and the space-time continuum works that will allow us to transport in different ways that we never thought possible before.
Well, LISA embarks on her 8-week mission, 8 weeks to potentially find those gravitational waves tomorrow, Thursday, and this hunt for Einstein's space and time ripples, if they exist, and can she identify them?